Hello everyone. In this video, we will be discussing about second topic in module 1, that is steam formation. So, generally, what do you mean by steam? Steam is nothing but the water which is in the gaseous phase. It is commonly formed by boiling or evaporating water. Steam that is saturated or superheated is invisible. However, steam often refers to wet steam, the visible mist or aerosol of water droplets formed as water vapor condenses. So here I have used the term saturated, supersaturated. So here we have very important concept to discuss. So that is the formation of steam at constant pressure. So this is the very important topic. So let me take a cylinder, and it's a closed cylinder, and inside let me take a volume of water, for example 1 liter of water at 0 degree Celsius, and let me keep a movable piston with some weight over this volume of water. Now, and the same thing, let me, theoretically, let me compare it with the enthalpy temperature graph, where the x-axis is plotted with enthalpy, which is denoted with H, and the y-axis is plotted with the temperature, it is denoted as T. So let me take a water of 1 liter of volume at 0 degree Celsius here. Now, what I will be doing at constant pressure means normal atmospheric pressure I am talking about. When the water, when I supply the heat source to this water, gradually the water temperature rises. So you can able to see here, this indicates the temperature of water rises. You can able to see the temperature y-axis. So the temperature of the water rises, and you can able to see here when the water temperature is rising, like the expansion of the water, we can able to see this. So water is expanding, and once it reaches this saturation temperature. Saturation temperature is nothing but the boiling point temperature. We know, like at 1 atmospheric pressure, the boiling point temperature of water is 100 degrees Celsius. So assume that once the water is reaching the saturation temperature, the water starts converts vapor, like water phase, into the vapor phase. You can able to see this. So there will be a rise of temperature till the water reaches this saturation temperature, and later there will not be any stoppage of the heat supply. There will be a heat supply, but this heat supply will be utilized only for converting the this vapor, that is the wet vapor, into the dry vapor. So this phase we call it as a latent heat. You can able to see here, first portion, that is from A to this B part, it is called as the sensible heat, where depending upon the supply of heat there will be a rise of water temperature. But from B to C, that is from the wet vapor to the dry vapor condition, where there will be a temperature supply will be there, but there will not be any rise of lower of the temperature. So these particular B to C temperature we call it as a latent heat. So here the process of wet steam into dry steam will takes place. Here you can able to see this liquid plus vapor mixture. If I am talking about this point where 50% of the vapor will be there, 50% of the moisture will be there. This particular starting point you can able to see here, where 0% of the dryness will be there, 100% of the moisture. So when it is gradually increasing, for example, let me take this particular point where 75% of the dryness will be there, 25% of the moisture will be there. So like this. And moving to the next one, once it reaches the dry condition, again once it reaches fully dry condition, you can able to see the volume has been drastically improved, and again the same saturation temperature only is there where the dry steam is achieved. Now still there is no stoppage of heat supply where I will be supplying the heat. So when the heat is continuously supplied, again there will be expansion. So even though a piston is kept over the this top of the water surface, but still because of the expansion of this vapor, the piston will move up. This shows that the temperature as can able to increase the weight of so and so W. So now from the C point, if I keep on supply the heat, the steam will keep on improve its temperature and pressure. So that increase of temperature only, steam only, we calling it as the superheating phase. And finally, what we are getting is nothing but superheated like superheated vapor we will be getting. You can able to see here from the portion C to D, where the temperature rise is there from the it is a dryness point only, but C to D, the along with the dryness, like the temperature and the pressure has been increased. So this particular portion is called as the specific heat into superheated temperature minus saturation temperature. And this entire portion is called as the, that is HF plus HF plus Hg. We call it as the, like the internal energy or the enthalpy supply, and this is nothing but the overall energy enthalpy. We call it as the overall energy enthalpy. And we have three states of steam. So what is the three states of steam means? As I told you, we have wet steam, we have a dry steam, and we have a super heated steam. So the steam as it is being generated can exist in three states, that is the wet steam, dry steam, and superheated steam. From the graph we can able to see this. This is the wet steam condition, this is the dry steam condition, and this is the superheating condition, superheated condition. So how can we define wet steam, dry steam, and superheated steam? So wet steam is defined as two-phase mixture of entrained water molecules and steam at saturation temperature. Then move into the dry steam or dry saturated steam. It can be defined as wet steam is heated further, the water molecules in the steam get converted into vapor. So dry steam is the steam at saturation temperature having no water molecules in it at point C, that is there is no moisture content at point C. Fully the steam will be in the vapor, the steam will not be having any moisture content. So next one is the superheated steam. So it is defined as the steam which is heated beyond its dry state to temperatures higher than its saturated temperature at the given pressure. So when you are writing the content for this formation of steam at constant pressure, this TH diagram is compulsory, and all this construction and the explanation process we need to write, and along with these basic definitions. So this completes this particular formation of steam at constant pressure. Here we have one more condition also. If I can able to increase or decrease the pressure according to the pressure conditions, even the temperature and even the process also will vary. It means like there will not be any change in this graph, but the time matters. In case if I am going with a high pressure condition instead of the atmospheric condition, if I am going with some 3 bar or 4 bar pressure, means where the water gets heated up so quickly. So accordingly the time rate will be increasing, but there will not be any change in this particular process. Thank you.